So like I said, we're doing functions, and these first two questions are from the IEB or an IEB paper. And guys, IEB papers is not something to like be fearful of or to not revise. They're very nice papers to go and see how things are tested slightly differently. And not like hugely differently, just particularly like the more complex questions are very interesting complex questions. And it's good for you to practice those sorts of things so that when you do encounter something a little bit different, you're fine. So this first question we have here says, in the diagrams below, the graphs of f of x equals root kx and g of x equals log a of x are given. Note, O represents the origin. The graphs of f and g intersect at the point B1. Okay, so we do have our graphs here that's been given to us, and we know that this coordinate of B is at 3, 1. Here's the O that represents our origin. We all should know that. It's very rare we ever label it something else, and if we do, we will say so. And then importantly, just in terms of the type of graphs you have, f of x is a root function, and so that would mean its inverse is a parabola or quadratic. And then g of x is obviously a log function, which means its inverse would be an exponential function. That's not how you spell inverse, is it? Right, now the reason I'm making the statement is because that 9 times out of 10, if you're given a log or a root function, somewhere along the line, a question on the inverse is going to come up. And so it's important that we can immediately, through analysis and comprehension of our question, guys, I'm sorry, I don't know. Through analysis and comprehension of our question, sort of anticipate what's going to be asked of us. And not just anticipate, oh, I'm going to be asked an inverse. Anticipate that, okay, I'm going to be asked an inverse, and the inverse of a root function is a parabola. The inverse of an exponential equation is a logarithmic function, or whatever the case may be. Because immediately when you start doing those questions, you kind of know what answer you should be looking for. All right, so the first question says, determine the values of x represented on the sketch for which f of x equals, oh guys, I don't even know. Apparently my eyes aren't working either. F of x greater than g of x. Now again, I know these are not particularly questions that we enjoy, these inequalities. However, you're going to get a question on them. You have to be able to deal with them. So you are going to answer this by yourselves in a second, but let's just understand what this inequality means. So f of x greater than g of x, basically it's asking us where f of x is above, so sitting on top of g of x. That's what we want to look for on our graph. Right, so this is a 2 marker. I'm going to give you 2 minutes to write down an answer for me, and then we'll have a look. We can chat about why the answer is what it is, but let's give this one a try. So like I say, guys, I'm going to get you to do a lot of them independently. If you choose not to, that is obviously your choice, but you need to practice it. I'm not going to be writing your exam for you. Your parents aren't going to be writing your exam. Your mate isn't going to be. You are the only one who's going to be putting pen to paper in finals. So practice it now. Get it right now. Get it wrong now. But practice it now so that you know sort of what your game plan is in terms of studying. Right, 2 minutes, and then we will see. And again, please put your answers in the chat so we can see if we agree, disagree, and we can go from there. Okay, Kanye, that's looking good. I just want you to think about the asymptotes, specifically the asymptotes of your log graph. but you are definitely on the right track here. Okay, that's our 2 minutes. Now, guys, the reason I'm giving you 2 minutes, although I'm sure most of you know, is because it's 2 marks, a mark a minute. We've discussed this idea. Hopefully we understand that in terms of time management in your paper, that is sort of your goal that you should be working towards. If you can do a mark a minute, what that means is you should have about 15-20 minutes at the end of your exam to go back and check, to go back to questions that maybe you weren't able to answer or that you didn't get a chance to answer. A mark a minute guarantees that you're not wasting time on questions, as well as guarantees that you do have time to check your answers. All right, so let's have a look here. Okay, guys, apparently I can't speak English today. I'm not a very functioning human today, so we're just going to roll with it. So in terms of this question asking us is, where is f of x above g of x? Now, f of x is a slightly darker line in terms of our two graphs. And so we can see that f of x is only above g of x for this sort of portion that I'm overlapping or sort of highlighting in green over here. Here, it's above g of x. For the rest of it, it's below g of x, which is not what we want. We want where it's above. Now, we are looking for the x values on the sketch. Now, at this point over here, at the origin, we know that x is equal to 0. And at this point B, we know x is equal to 3. So we have our x values. We now just need to decide, do we include, do we exclude? What are we talking about? Now, I said earlier that we need to bear in mind asymptotes. Remember, an exponential function will have an asymptote if it's not shifted up or down with the x-axis. Because of the swapping characteristic of an inverse, your log function has an asymptote on your y-axis. So we can't go past 0. So we can't go to any of our negative x values because the log graph won't exist there. It is only between 0 and 3 in terms of this inequality. Now, we don't include either of these values. A, because 0 is an asymptote, but B, we always go back to the original question. If there was an equal sign with this, so f of x equals to, f of x is greater than or equal to g of x, then we would have to consider putting an equal somewhere. But in this case, we don't. There is no equal, so we just say it's between 0 and 3, and that's it. Just for sake of, if it had said f of x greater than or equal to g of x, we would not be able to include the 0 because that's our asymptote, but we could include the 3 because that is a point of section, whatever that was, point of intersection, which is where f of x is equal to g of x. And if it included the equals, it would be greater than or equal to. So we should include that point of intersection. Right, in this case, in terms of the mark allocation, this is not really how DBE marks, and we've discussed this mark allocation. Usually it's an all or nothing mark, so 2 marks or 0. But in this case, you got a mark allocation for understanding that it needed to be x greater than 0, and then a mark allocation for understanding x less than 3. So sort of the idea of there is a range of values between 2 defined x values. Right, question B says determine the values of k and a. K and a are obviously in our equations up here. So f of x has the root k of x and g of x has the log a of x. So what I'd like you to do is I'd like you to find the value of k and a. Basically, you're solving for some unknowns in your equations. And we need to think back to, if I need those unknowns and they represent my graphs, how am I going to go and solve for the unknowns? Right, so 4 minutes, 4 marks, 4 minutes, and then we'll go. Again, guys, this is also going to just help you because I'm giving you 4 minutes on the dot. it's going to help you assess whether or not you manage your time effectively. If you are only getting halfway through this question, you're spending too long on the question, and you need to be able to quicken your pace in terms of answering questions. Right, again, you can put answers in the chat so we can see. Please don't feel like you can't get it wrong. You can get it wrong. Even if you put a wrong answer on the chat, it's fine. We'll discuss how we can correct it. That's the whole point of these lessons, is to learn, correct, adjust as we go along. Right, so A and K, let's see what we get. 4 minutes. Nice, guys. Well done. The rest of you, 2 more minutes. Or minute and a half, 90 seconds. While everyone's wrapping up, Tuariso or Lelo, or both of you, what method did you use? So what did you do to go and find K and A? Excellent. Okay. Right. So that's your 4 minutes. It goes by a lot faster than you think it's going to. Right. So exactly, we substitute our point or a point on the graphs. In this case, because B is a point of intersection, it exists on both of the graphs. We can substitute it into both. So on the left-hand side here, I substituted in my coordinate of B 3, 1 into f of x. So 1 was equal to root k times 3. From there, I was solving for k. Right, so from this point over here, guys, that's just my substitution. I don't want the square root, so I'm going to square both sides. But 1 squared is 1, and that's why I no longer have the root on the right-hand side, because I squared both sides. We then want k alone, so we would divide both sides by 3, and so k is equal to, excuse me, a third. All I've done at the bottom there is just written my expression for, or my equation for f of x. You don't have to do that. The question didn't ask you to do that. However, we know that it is potentially useful to us. Right, just in terms of mark allocation, I'm on it today. For this specific half, we will get a mark for substituting in our point B and a mark for our answer. Thanks, Ayla. And then for g of x, we do exactly the same thing, right? We substitute in our coordinate for B, a mark, and a mark for our answer. Now, just that we understand how we do get to this answer, from this point with the log, we would need to convert back to our exponential form. So this is converting to the exponential form so that we can go and solve for A. So remember, this a value over here is your base. Whatever the log expression is equal to, that is your exponent. And this 3 or whatever the brackets is over here, this is essentially the value of the power or of the exponent. So the base of a to the power 1 is equal to 3. So that is my conversion. And I am then able to essentially find what a is. Just make that a touch. That didn't really work like that. Alrighty, question C is asking you to determine f to the negative 1, the inverse of f in the form y equals. Right, so there is a reason why I wrote down f over here. I now have the equation. I'm going to use that to find the inverse. So again, 3 minutes. I want you to tell me what the inverse equation is here. And it's in the form y equals. Now remember, guys, we already said right at the start that the inverse of f should be a parabola. So I want you to think about that carefully. That is what your goal is. We did also speak about inverses of parabolas on Monday. So hopefully some of that information and what I said to you is going to trickle back in. And we're going to remember some important things. Right, 3 minutes. Remember, you're welcome to put your answers in the chat. 1 more minute. Alrighty, guys. Okay, Toriso, I like that answer that I'm seeing. Okay, guys, so remember we said, and this is again why it's so important that before you jump into a question, you just analyze what's happening. We said over here that we know that the inverse of f is going to be a root function. Sorry. And that means that that's what the inverse of f, which is a root function, is going to be a parabola. And so that's why we knew what to expect coming into this. All right, so first things first, remember we swap x and y. There's a mark for you so that you are able to go and solve for y. Don't know why my brain is like this today. I really do apologize. Hopefully it's going to get better, but anything's possible. And then you solve for y. So we get rid of the square root. We square both sides. I don't want the third, so I would times both sides by 3, leaving me with 3x squared. Now, importantly, it says state its domain. Now, we had this discussion on Monday where we spoke about the fact that in order for a inverse function of a parabola, so in order for a root function to be a function, we would have to restrict the domain. All right, so remember, this would be a positive quadratic function. So we would have a happy face, something like that in terms of our parabola. If we were to now go and reflect this over the line y equals x, our inverse would sit something like that. And because of our horizontal line test, that is not a function. And so what we do is we end up restricting the domain. So for the graph that we've been given here, we are only working with the positive x values of my root function, which means that when I go and find the inverse, I'm only working with the positive x values of my quadratic. So this stating of the domain is this situation that I have over here. I'm only working with the positive x value, so x greater than equal to 0. Your third mark, obviously, coming from getting the actual equation y equals 3x squared. So please don't forget to state that domain restriction. We spoke about it on Monday and how specifically for root functions, it is incredibly, incredibly important because unfortunately a root function without a restriction is not a function, it's a relation. And so we have to make sure we restrict our domain. All right, so, sorry. Let's take a screenshot of this first question. I'll just do this so that you can see the IUB thing if you want that. And then we'll have a look at the next one. All right, so guys, again, please don't forget that domain restriction, especially for root functions, parabolas, incredibly, incredibly important. All righty. Right, so the next question here, we want to sketch the graphs of f of x, which is equal to 3 to the power x plus 1, and g of x is equal to 3 to the power 2x on the same set of axes. Show any asymptotes, intercepts with the axes, and points of intersection. All right, quick question. What type of graphs are f of x and g of x? Rato?
Ma'am, aren't they exponential functions?
Excellent. Okay, so these are both exponential functions. Awami, Leila, very, very nice. All right, so when you sketch these graphs, just bear that in mind. They are both exponential functions, so you should have 2 exponential graphs. All right, so I'm going to ask you to sketch these graphs. I don't think it'll take you 6 minutes. I'm going to give you 5. We'll see how you go. Remember, you have to show all of the asymptotes that need to be shown, any intercepts with the axes, and points of intersection. Okay, so that's really important that we do actually go and show all of these things. We can chat about how you would find all of them now in a second. I can't underline, so let's just chat about it now. Asymptotes, remember, an exponential equation only has one asymptote, a horizontal asymptote. And that is determined by your Q value. Now, in both cases, there's no Q value. So your asymptote here is actually just the x-axis. So we're not too stressed about that. Intercepts with the axes. If you want your y-intercept, you need to make x equals 0. And if you want your x-intercept, you need to make y equals 0. Now, again, guys, think about this logically. If your x-axis is your asymptote, you can't have any x-intercepts. That's not possible. So you don't even need to stress about trying to find those right now, because for this specific context, that's not possible. If there was a shift up or down, then yes, potentially there is going to be a x-intercept. But in this case, because that's actually your asymptote, you don't even need to bother with it. Right, and then the next thing it asks for is your point of intersection. Okay, so let's give this a go. Like I say, 5 minutes, and then we will see what beautiful graphs we come up with. Sorry, I realized I just stopped. Points of intersection, remember, it's where your two graphs are equal to each other. I know we know that, but I was explaining everything else, so better finish the job. Where we make them equal to each other. Right, 1 more minute. If you're not stressed, if you're not quite finished, don't stress. You can kind of fill in what you need. Alrighty, let's see what we have. No. Okay. Right, so there are two graphs. The y-intercept should not have been too much of a problem. The only thing I'm just going to chat about is the point of intersection. Just because this is an exponential equation and we might not have practiced it recently. So remember, this is where we're going to make f of x equal to g of x. And so we're going to have 3 to the power x plus 1 is equal to 3 to the power 2x. Remember, the whole premise of exponential equations is in order for two sides to be equal with exponential equations, the bases must be the same and the exponents must be the same. So once we have the same bases, all we do is we go and equate the exponents and we solve for x. So this would be 1 is equal to x, or x is equal to 1. Doesn't really matter. And so once you have that x value, you would go and substitute it back into one of your other equations. So if, for example, I substituted it back into f, so I wanted f of 1, 3 to the power 1 plus 1 is 3 to the power 2, and so 9. So that is my point of intersection that I need to draw. Okay, kind of good question. So the question is, how do you know if the graph is increasing or decreasing? So there's a couple of things that we can look out for. So I'm going to give you, hopefully, what will be a relatively brief summary. But let's see how we go. Right, I will show the mark allocation in a second, but let me just chat about this quickly. So it very much depends on whether A is positive or A is negative. If A is sorry, I was just making sure I didn't write the inequality twice. If A is positive, we have two scenarios. We either have a scenario where your base is then greater than 1, or we have a scenario where your base is a fraction. Okay, so as an example for this one, this would be y is equal to 2 to the power x versus y is equal to a half to the power x, for example. Now, because it's positive 2 to the power x and positive a half to the power x, whenever A is positive, what that means is it sits above your asymptote. So when we now draw these two graphs, it must sit above this asymptote. And we know it's that asymptote because I haven't got a Q value here. I'm keeping it quite simple. Right, now obviously you could just go substitute in values for x. However, let's just think about this logically. If we look at the first equation, 2 to the power x, and we just kept increasing the value of x. 2 to the power of 0, 1. 2 to the power 1, 2. 2 to the power 2, 4. 2 to the power 3, 8. 2 to the power 4, 16. As my x values increase, my y values increase. If we go on the other side, 2 to the negative 1, a half. 2 to the negative 2, a quarter. 2 to the negative 3, negative an eighth. They get closer and closer to your asymptote. So what's going to happen here is let's try that again. You have got an exponential function that is increasing. Right, whereas if it's a fraction, it is decreasing. Because again, if we think about this, for geez sakes, if we just think about this logically, that's a terrible, terrible exponential function. A half to the power, let's say, for example, negative 4 is going to be 16. So that's why it starts up here and it starts decreasing, because at negative 4, we would have 16. At, say, for example, negative 2, we would have 4. At 1, a half to the power 1 is a half. At 2, a half to the power 2 is a quarter. It's going to start decreasing like that. So it very much depends on your B value. When A is negative, this is where things are a little bit weirder. This now means it is below your asymptote. And basically, it's a reflection of these graphs that we've spoken about. So if B is greater than 1, all that's going to happen is that this graph I've just drawn is going to flip over my x-axis. So now let's say, for example, we had y is equal to negative 2 to the power x. My graph now decreases from left to right like that. You can see it's a reflection over the x-axis. And then if B was a fraction, So let's say y is equal to negative a half to the power x. Again, it's a reflection over your x-axis below the asymptote. So this would now increase from left to right. These second ones, so where a is negative, those are a little trickier. But all you just need to remember is if you can remember this or these properties that I've outlined here, all this is to get over here is a reflection. So it very much depends on B, and that will then tell you whether or not it's increasing or decreasing. Okay, good question. I know, I was going to say I'm pretty sure. In the paper 1 information pack that I put on the Google Classroom of the trial exam period, I think I have done a summary of all of this stuff in a much neater fashion. So it is all there if you want to have a look at it again. Okay. If we have a look at question B here, and I'm going to do this one with you because it's not a particularly hard question, so you are welcome to try it by yourselves. But I do think it's one where we might panic a little bit, and there's no reason to, so let's have a discussion how we deal with it. So question B says, rewrite the equation a to the power 2x equals 3 to the power x plus 1 in the form x equals. So this is now a bit different to what we're used to. Usually we're used to being told write it in the form y equals. But now we're being asked to write in the form x equals. Now remember, what this essentially means is that we need to solve for x. So if we want to solve for x, we want to get x alone. But my problem is that I've got x in 2 exponents here. My bases aren't the same, so it's not even like I can just add the exponents or divide the exponents or anything like that. So I need to be careful. So if we think about this, a to the power 2x is just a to the power 2x. It is what it is. But on the right-hand side, 3 to the power x plus 1 can be written as 3 to the power x times 3 to the power 1. Because remember, your exponent rules say that when we have the same bases and we are multiplying, we just add the exponents. So 3 to the power x plus 1 has come from me saying 3 to the power x times 3 to the power 1. Now that I have this situation, again, my goal is to solve for x. So I kind of want to get these two x's, the a to the power 2x and the 3 to the power x together. I'd like them to be together because then maybe there's a way for me to get x alone. So in order for me to bring this 3 to the power x to join the a to the power 2x, I'm going to have to divide both sides by 3 to the power x. That's the only way I'm going to get it onto the left-hand side, by getting rid of it on the right. And so I end up with a to the power 2x over 3 to the power x is equal to 3. Now we're on the right track. Let's maybe fix that 3 because it was a little strange looking. Okay, it didn't get better. Now I'm on the right track. At least now I've got my x's on one side of my equation. Now again, this all relies on your exponent knowledge. We know that, let's say, for example, I had a half to the power 2. We know that that 2 would distribute to both numerator and denominator. Because I've got a power x in both numerator and denominator, I could write this as a squared over 3 all to the power x, because then I would distribute the x to top and bottom, and I would end up back at 3 to the power 2x over 3 to the power x. Right, that's great. That is an ideal situation for us to be in because of the fact that now instead of 2 x's, I just have a single x exponent, and now I can work with that. Now remember, the question said we need to solve for x. Because x is in the exponent here, I'm going to have to convert it to a logarithmic expression. Right, so log, let's try to write log again. Log of my base, a squared over 3 to 3, you don't have to put it in brackets, is equal to my exponent, x. And this is now in the form they wanted us to write it in. X equals log of my base, a squared over 3 to the 3. Whatever that is. Okay, so what I want you to remember is in questions like this, and just in general, when you're asked to solve for a variable, x, y, p, q, whatever, the goal is to try and get one term with those variables. And it is sometimes going to require you to, in an exponent situation, apply exponent laws that you know. In a situation whereby you have multiple terms, potentially having to factorize out your variable so that you then just have that single variable as a factor. And so we just need to go back to all of our algebra in order to deal with questions like this. Excuse me. So please just bear in mind that your exponent rules, your factorization rules, all of those things that we have learned already do come into play in questions like this. Right, Lorato?
Ma'am, do you mind just re-explaining this question, because my network was like kind of you kept on breaking on my side, but it's my network. So okay, if you don't mind.
Yeah, I'll do it quickly. I'm going to do the mark allocation, so I will re-explain as I do the mark allocation. All right, so quick six, just the mark allocation for the drawing of the functions in question 7a, just so that we know what's what. Excuse me. You are going to get a mark for, how many marks is this? 6 marks. You're going to get a mark for the Sorry, there's this person who drives the loudest motorbike on our road, and I just would like to do something to it. Anyways, you get a mark for the shape of your functions. Okay, now because both of these are exponential functions, you get in 1 mark for shape. Sort of because if you can't draw one exponential function, you probably can't draw another. So you will always get a mark allocated for the shape of your graph, parabola, hyperbola, exponential, whatever. So that's why it's so important that you draw your graphs nice and neatly. Right, you get a mark for your point of intersection because you were told to plot that. You get a mark for your intercepts, and you're going to get a mark for your horizontal asymptote to both of the graphs. So understanding that both graphs have a Q value essentially of 0, and that your horizontal asymptote is at y equals 0, so on the x-axis. So those are your 6 marks. Personally, I probably would have allocated the other mark to the shape of your second graph, but I mean, it depends. I actually wouldn't have made I also wouldn't have made the 6 marks. I would have made it 5, but it doesn't matter. That's how the marks are allocated in this case. Right, in terms of the next question, this was only a 3-mark question. So the question said, write this equation in the form of x. So that means we need to solve for x. So what we want to try and do is we want to try and group the x's together. So that's why I divided both sides by 3 to the power x. So at least I had the x's both on the left-hand side. Once you had done that, we needed to go back to our exponent rule that says to us, if we have a fraction whereby the exponents have something common to them, we can write that as that fraction to the power of that exponent. Because if I distribute the power x back into our bracket, we have a to the power 2x over 3 to the power x. Once we have that, we can now use our log conversion to get our expression in terms of x. Okay, it's not super tricky. I think the trickiest part is understanding that we need to try and get all the x's together. And to do that in this case, we have to apply our exponent laws. So your first mark is essentially going to be at this point over here. So you do have to do a fair amount of work before you actually get to a mark. That is essentially the application of your exponent laws. Your second mark is the application of your logs and then writing your answer correctly. So it's almost like a 2-marker for the answer. But essentially what will happen there is that if you understand that you needed to use logs, but you did something weird, you'll get the log mark, but you might then use the answer mark. So it's almost like a method understanding to use logs mark rather than like 2 marks for the answer, if that makes any sense. All right, so I've just made it a bit smaller so you can screenshot everything. Hopefully that all makes sense. And then we'll move on to the next question. Lorato?
Ma'am, so with question 7.a, we don't exactly get like any marks for like working out the point of intersection or the intersects. It's just showing the right points that you get the marks for.
Yeah.
Oh.
Yeah. Yes, unfortunately, that is true. So anytime you sketch a graph, guys, oftentimes you do have to do some sort of working out. Like Lorato says, you have to go and find the x-intercepts or the point of intersection, whatever. We don't give you marks for it. We give you marks for the graph. So you have to do all of that working out and plot it correctly in order for you to get the mark. It's mean. Sometimes we're nice and we might say like question 7.1, determine the x-intercepts of the function, 7.2, determine the points of intersection, and then 7.3, sketch the graphs. And so then we will allocate marks for working out in those previous questions. But if we just jump straight into sketch the graph, then no, unfortunately, there's no allocation for marks in your working out. Okay. Like I say, a bit mean, but unfortunately, it is what it is. Right, I hope we've all taken screenshots. I'm moving to question 8. All right, so question 8a, it's kind of not quite similar to the question we had on Monday, but sort of requires the same sort of deductive reasoning. So question 8a says, explain why the equation 2x minus 1 to the power 2 equals -5 does not have any real solution. So I want you to just look at this for a second. You can give me an answer if you want, but I want you to try and explain to me why this expression, so the bracket squared, does not equal, so does not have any real solutions in terms of -5. So why does the bracket squared not equal -5? That's essentially what this question is asking you. So have a think. Like I say, if you've got an answer, or if you think you have an answer, raise your hand, put in the chat, whatever you want. I'm going to give you 1 minute to think about it, and then we'll chat about why it potentially doesn't, unless someone gives an answer. Any thoughts? Okay, you're going to kick yourselves when I tell you, but it's fine. All right, so you can't get a negative value when you square an expression. Lovely, lovely, lovely. Okay, so sorry, brain fart. Exactly. When we square a value, so it doesn't actually matter what 2x minus 1's value is. It could be positive, it could be negative, it could be a fraction, it could be a negative fraction, whatever. If we square it, we will never get a negative answer. It's just not possible, okay? So essentially, because of the fact that 2x minus 1 squared will always be positive, there is no real solution. So it does say explain why, so you would need to give some sort of explanation. But essentially, it's because that value of a bracket square can never be negative. And so it's not possible to have any real solutions. Now, if we think about what this means in terms of like a graph of a parabola, no real solutions of a parabola means that the parabola doesn't intersect the x-axis. So there will be no x-intercepts. So if you now have a look at this next question, I'm saying on this set of axes, sketch the graph of y is equal to 2x minus 1 squared plus 5. All that's happened is I have used inverse operations to add 5 on both sides, so that I've got y equals. And so because we have just established that this expression does not have any real roots, we should then be able to sort of make the link that there are no x-intercepts. And even if you go look at the question, it says show the coordinates of the turning point and the y-intercept. It hasn't said showing all intercepts with the axes or showing the x and y-intercepts. It's just said y. So that should also just give us a clue that we're not going to have an x-intercept. Right, now, like I said, this is a parabola. I know that because it's squared. Remember, anything that's x squared or has a squared is going to be a parabola. If your exponent is an x, exponential, and if your x is in the denominator, hyperbola. So I want you to sketch this graph, bearing in mind that the format I have given you is particularly helpful in showing some of your coordinates here. So I'm going to give you 3 minutes to draw your graph. It doesn't have to be a beautiful graph. Just get the shape more or less, and then we'll have a look. Layla?
Hi, ma'am.
Hi.
Ma'am, I wanted to ask, like, say for example, for question 8A, like, I didn't know the thing about, like, let's say in the exam, I didn't know the thing about the square thing that you don't get a negative for, like, that whole thing. And I just write there for any x value I substitute, it doesn't equal -5. Would I still get that mark?
Honestly, it would depend on the examiner, because the thing is, if you're saying any x value, it would mean that you've tested all infinite number of x values. I would potentially rather say, regardless of whether you substitute a negative or a positive x value, you still get a positive solution. That's a little bit better. But yeah, I mean, like, if you can show it, that's okay, but then try and go negative positive to show that regardless of the sign of your value, you're still getting a positive. Does that make sense?
Yes, ma'am. But like, ma'am, when you're saying I'm gonna show it, like, would I have to like write there all the things that I tried and then like say based on this, it doesn't work?
Kind of, yeah. Yeah, we would need to see some sort of working out. Obviously, I mean, so like I said, I would maybe start then with like a +1 and a -1. And if you can see that that relationship exists, then cool, you can now say it. But yeah, we would then need to see all your working out that you've done in order to come to that conclusion.
Okay, thank you, ma'am.
Yeah. Pleasure. Alrighty, guys, let's have a look at this graph. So there it is. Just very quickly, in terms of what you've been given here. So remember, the form of the equation that we've given you is in a turning point form. But what might throw us is that 2 in front of my bracket. Excuse me. So what we need to remember is that in order for us to get our turning point, our equation needs to be y is equal to a, x minus p squared plus q. What's actually happening here is our a value has sort of been put into the bracket and it's part of the square. So we need to be really careful when we have a look at a question like this. So our turning point is not at 1, 5. It's at a half 5. And that's because we need to, we need to take into account that we would have to divide both of those by 2. Now, if that's not something you're super comfortable with and you got to this point, you're like, oh, I don't actually know what to do with the 2, that doesn't matter. Remember, there's other ways to do this. If you go and expand this bracket, so you say 2x minus 1 times 2x minus 1, and you essentially go and distribute out your bracket squared, you will get 4x squared minus 4x plus 1 plus 5, which is 4x squared minus 4x plus 6. And we know to get the x coordinate of your turning point, we say minus b over 2a. So minus -4 over 2 times 4. And that gives you positive a half. So you are welcome to distribute it out and go and do all of that if you are not comfortable with the equation in this form. And then obviously 5 is the y value of our turning point. And so if that's what you need to do and you aren't super comfortable, great. But just remember this 2 needs to be taken into account when we look at our turning point. The y-intercept, remember y-intercept is where you make x equals 0. It is not 5. This is really important. The turning point form of your equation, that constant, that +5, is not the y-intercept. That is the y-coordinate of your turning point. So you would still need to substitute x as 0. So 2 times 0 minus 1 squared plus 5. 2 times 0 is 0. So -1 squared is 1 plus 5, which means our y-intercept is at 6. So please just be careful. It's this constant over here is the y-coordinate of your turning point, not the y-intercept. So this question, I want to say like misleadingly easy. I don't know if that's like the right way to describe it, but misleadingly easy in the sense that You're just drawing a parabola. You have all of the information here, but we just need to think carefully about a few things before we just jump straight into the answer. Right, before I move down, just some mark allocations. So the first one, obviously, just understanding that a bracket squared cannot be equal to a negative. It would actually be greater than or equal to, but understanding that concept. Again, you get a mark for your shape. In question B, you were told to show the turning point, so a mark for the turning point, as well as the y-intercept, so a mark for that. All right, pretty straightforward. Like I say, it's not trying to trick you, but we just need to think carefully about the turning point and the y-intercept. Right, if we look at question C, it says, describe how you would shift the graph vertically, so up, down, so that the x-intercepts are real and equal. Now, we had a discussion about a question like this on Monday, but we'll do this one together. So real and equal. Real basically means that they exist, so we do exist, so that we do actually have x-intercepts. And equal means that your turning point is your x-intercept. I'll do a quick summary on the side now of the different types of roots that we have. But real, they exist. We do have an x-intercept. And equal means that your turning point is your x-intercept. Essentially, what this would mean is that when you solve for your x-intercept, you end up with two of the same brackets. So we would have 2x minus 1, 2x minus 1 equals 0. And because those brackets are identical, your solution is identical. So you still have two solutions, they just happen to be identical. Okay, so if we go and have a look at our graph, and again, imagine you are shifting this graph. So here's my parabola. I want to move it up or down so that it now touches my x-axis. So essentially, I need to go from a turning point at a half 5, and I need to move this down so it touches my x-axis. All that's happening there is I'm taking this graph and I'm shifting it. Let's see if this is going to do what I want it to do. 5 units down. Because I now want this y coordinate to be on the x-axis. So I now want my turning point to be at a half 0. So my description is quite literally 5 units down. That's it. Right, just quick summary in case we struggle with the roots, because I think it's sometimes we struggle with these questions just because we aren't sure what it's saying about the roots. Real roots, they exist. They are x-intercepts. There are, okay. Words, English, writing, none of my strong suits today. Okay, non-real, no x-intercepts. And that's what we had initially. Okay, equal roots. Your turning point is on the x-axis, or essentially what that means, your turning point is your x-intercept. Right, you can also get non-equal roots. And basically non-equal roots is that you have two distinct roots. I'll draw little pictures for you now. Two distinct roots. Okay, so real, basically you do have x-intercepts. They could be anywhere. I'm just going to make this up. You have x-intercepts. Great. Non-real, no x-intercept, sits above the x-axis or below the x-axis. Doesn't really matter. Equal, your turning point is on the x-axis. So there it is. Two distinct roots or non-equal roots would be something like this. These are terrible diagrams. I'll try that again. And there we go. No. Something like this. That value is very clearly different to that value, so they're two distinct roots. Yeah, so that's kind of like a graphical summary of roots when it comes to quadratic functions and quadratic equations. Question D is now saying solve for x in terms of k. If 2x minus 1 squared equals k, and write down the values for k for which the equation has real roots. So we've just done a quick summary of what that means. Real roots means that the roots exist for this expression. Oh, I'm getting too old. All right, so we're solving for x in terms of k. So again, isolate x from this expression. And so what that means is I'm going to have to distribute out this one situation. So we have actually done this already, so I don't know why I'm rewriting it. If you're not too sure what I'm talking about, just going to give it a second to assess some of its choices. Okay, if you don't know what I'm talking about, up here, we've already expanded that bracket squared. So I'm not going to do it again. There's no need for me to do it again. Obviously, you can if you want to, but there's no need. So we get 4x squared minus 4x plus 1 is equal to k. And then, like I say, now what we're trying to do is we're trying to solve for x. Okay, there's a couple different ways that you can go about doing this, but obviously what we need to kind of think about is if we're solving for x, and this is a quadratic equation, if I can't factorize it, I would use my quadratic formula, which means I need to put this whole situation into standard form. Now, again, what often trips us up is we don't understand what k is. K is a constant, which means that it is part of my c term. So in ax squared plus bx plus c equals 0, it is part of that c term, which means it and the positive 1 are like terms. So what we need to go and do here is, like I say, get into standard form. So 4x squared minus 4x plus 1 minus k is equal to 0. You can put the brackets there if you want. The only reason I'm putting the brackets in is to remind us of the fact that this is my c term, this is my bx term, this is my ax squared term. That's the only reason I'm putting the brackets. You can if you want, you don't have to. And now what we're going to do is we're going to use our quadratic equation to solve for x. So x is equal to minus b, so minus negative 4 plus or minus the square root of b squared, negative 4 squared, plus 4ac, which is 1 minus k, all over 2a, which is 2 times 4. And now we can neaten up this whole situation in order to get a nice simplified expression. Right, guys, this is just distribution algebra. So the negative times the negative is positive 4 plus or minus my square root. I'm going to simplify what's going on underneath there. So negative 4 squared is 16. And if I now look at the second term, 4 times 4 is 16. And I will have to distribute that into my bracket 1 minus k. In my denominator, 2 times 4 is 8. Now, grade 12s, you cannot simplify the 4 and the 8. There are separate terms in your numerator. You cannot divide away terms over a plus or minus. So we can't just cross-cancel nonsense here. That is mathematically incorrect. So let's keep simplifying our root. So underneath my root, like I say, I'm going to distribute. So I've got 16 plus 16 minus 16k all over 8. And I end up with x is equal to 4 plus or minus the square root. 16 plus 16 is 32 minus 16k over 8. All right, so we just need to be very careful there when we go and distribute. Minus b, oh gosh, b squared. So glad everyone's on it. There's a mistake in my formula. B squared minus 4ac. What a nana bean. That's why you have a formula sheet in front of you. Right, let's fix that. Minus 4ac, so this would be minus, distribute that in, minus 16 plus 16k, 16 minus 16 simplifies out 16k. Right, I knew I was losing my mind somewhere. Okay, what we can now do is we can square root the 16. So x is equal to 4 plus or minus, the square root of 16 is 4 root k over 8. And now what you can do is oh gosh, let's carry on up here. Now what you can do is you can take out a common factor of 4 in the numerator. So x is equal to 4, 1 plus or minus root k all over 8. Now you can go and divide. So 4 divided by 8 is a half. So 1 plus or minus root k all over 2. That is our value for x. We've just done the solution for solving for x. Seems like a lot of work for 3 marks, but there we go. Okay, so once we have got our solution for x, we can now answer the second part of our question, which says the equation has real roots. Okay, so real roots basically means that they exist. So let's think about what would happen if they were to not exist. So let's just change our color here so that we know what we're doing. So if I had non-real roots, do you agree that the only way for this expression to be non-real would be if k was negative? If k was negative, I'm square rooting a negative value. It's not possible to get a value. So that would create a non-real solution, which means a real solution would be a situation where k is greater than 0. As long as k is positive, whatever happens underneath that square root will give me a real solution, which means I will have real roots. Okay, so understanding surds, exponents, all of those fun things all come into play here with this question. Right, now, like I said, this seems like a lot of work for 3 marks, and realistically it is, particularly because you have to simplify that whole gross quadratic equation. And so the marks, unfortunately, are a bit stingy. You are getting a mark for subbing into your equation, a mark for simplifying to get your solution for x, and then a mark for where they will be real. Okay, so a bit stingy, but unfortunately is what it is here. Toriso?
Ma'am, if I used a different method, such as instead of doing the quadratic formula, I square rooted both sides, and then I took -1 to the other side, making it plus or minus square root of k plus 1. Then I divided both sides by 2, making it 1 plus minus root k over 2.
I'm going to be honest, didn't even think about that. It's fine as long as you remember to say plus or minus with your root, because then you would have the 2x equals 1 plus or minus root k, x equals 1 plus or minus root k over 2, which is exactly the same thing. You've made my life easier. I just wasted about 5 minutes of everyone's time. Thank you. Oh, yeah. I always forget about the square rooting. I never use the square rooting because we always forget to put the plus or minus in front of it. So as long as you put plus or minus in front of your square root, I am happy as a lamb. That's absolutely fine. You'll get full marks. Okay. So I just choose to take the scenic route. Come along for the ride or make your lives easier. You decide. Okay. Right, let's take a screenshot of what we have done. There we go. We have all of our mark allocations. We do. I'm relatively on it tonight, despite the fact that I overcomplicate everything, can't write, can't read, all of that. Right, and then let's see what the next one has in store for us. We obviously won't finish everything I've prepped, but that's okay. You guys can go further if you want. Alrighty. I'm going to decide which one I'd like to do. Let's actually go to question 5 because this is a little bit nice and it works with an inverse. So question 5, 2, 4, 5, 6, 7, 8. Right. Question 5. You essentially, I want you to answer everything by yourselves in question 5. 5.3.2, you are welcome to try. I am going to do it with you just because it's a little trickier. But if you would like to try it, you're welcome to. We have got 11 minutes left of this lesson. I am going to give you 7 minutes to get through these questions because 7 marks essentially. Like I said, the last one I'll do with you. If you want to try it, go for it. I'm going to give you 7 minutes to answer 5.1, 5.2, and 5.3.1. We'll have a look at the answers, and then I'll finish off by doing 5.3.2 with you. You can check your answer, or you can do it with me, whatever you want. Ask me questions as you go along. Let's have a look at these. 2 more minutes. Alrighty, let's have a look. If you're not done, again, don't stress. Okay, so 5.1, guys, is to show that question. What that means is that, again, you can't use that A is equal to 1 over 25. You need to use other information that you've been given to show that that is true. So show that, prove that questions. You can't actually use A equals 1 over 25 when you're working out. You have to use the other information that you've been given to get there. Right, so as I go along, obviously, I'll do mark allocations. So first one, you're going to substitute in the coordinate that you have, so that A equals -2, -4. So you're going to get a mark for subbing in A, and then you're going to essentially get a mark for your simplification. Now, the reason that I've gone from my substitution to here, I would add 5 on both sides, and -4 plus 5 is 1. 1 over 5 to the -2, that is then positive 25. So that negative would flip the fraction to positive 25. Isolate A by dividing both sides by 25. Right, when we then get to 5.2, it says the coordinates of the x-intercept. X-intercept is where y is equal to 0. So I need to see that you substituted in y equals 0. I then essentially need you to use your knowledge of exponents and exponential equations in order to make your bases the same, and then finally getting your coordinate for the x-intercept. Guys, importantly, it's a coordinate, so write it as a coordinate, please. Generally, we do give you the mark at x equals -3, but it says it's a coordinate. Do what it's asking you to do, okay? It's just like a skill to learn so that you aren't missing marks when you've been asked to do something. Right, 5.3.1, you've been given h of x is equal to 1/5 to the power x, and we want the inverse. Remember, what we want to do is we want to swap x and y, and then we'll use the logs. Now, there's 2 ways you could deal with this. Either you could work with 1/5 to the power y, and then write your log, or if you wanted to write that 1/5 with a negative exponent, you could have 5 to the negative y and write your log as negative log 5x. Both of them are correct. It's absolutely fine. So a mark for swapping and a mark for your answer, and the same on the other side. So it doesn't really matter which one you go for. It's whatever you're comfortable with. Right, before I get to 5.3.2, Kela Bugile, question?
How did you get the 125?
Which question am I looking at? Oh, this one over here. This one, yeah. Okay, so guys, I got 125 so in the step before, I want to get the 1/5 to the power x alone. So what I essentially do is I times both sides by 25, because that gets rid of the fraction, and 5 times 25 is 125. Does that make sense?
Okay, ma'am.
Cool. So it's just my inverse operations. Lorato?
So, ma'am, multiplying the 25 on both sides wouldn't exactly affect the 1/5 fraction because it's already cancelled out the 25.
Yeah, exactly. So remember, this is a coefficient. It's like having 5 equals 2x. 2x. It's like having 5 equals a half x. By timesing both sides by 2, you're not affecting the x at all. It's a coefficient to the variable.
Oh, okay. Thank you, ma'am.
Sure. Alrighty. Right, let's have a quick look at this last one, just because I think it's quite an interesting one. And again, it brings in some exponential expressions. So it says, describe the translation from G to H. Now, I've just written both of those equations down for us again. So what G is and what H is. Okay, sorry, we're having a bit of a moment here. So there's G, there's H. We want to describe the translation. Now, guys, translation is left or right, up or down. So hopefully, fairly obviously, we could definitely say that if we compare the constants, there's a -5 and there's 0. Okay, so this will be plus 0. We can fairly confidently say it's gone 5 units up. But what about the left or right? And this is where your exponent knowledge comes into play. For exponential functions, remember, it would be a to the power bx minus p plus q. For exponential functions, your exponent, when it's a binomial, so x plus or minus a value, represents your shift left or right. So I now need to have a look at this first term over here and see if I can somehow manipulate that to get a single base with an exponent that is x plus or minus something. Now we can do that because remember, we want to get the bases the same. So this would be 1/5 squared times 1/5 to the power x minus 5. You can keep the -5 there if you want to. Sorry, I'm getting old. It's completely up to you. And again, using your exponent knowledge, what you need to bear in mind is that this 1/5 squared can be written as 1/5 to the power 2 times 1/5 to the power x. Your bases are now the same, which means you can go and add the exponents. And so we would have 1/5 to the power x plus 2, or 2 plus x, doesn't matter. But look at your equation. I wanted x plus or minus 5. And so again, what we can see is definitely shift 5 units up. But this expression tells me that it's gone 2 units left. And so this is the description of my translation to get from G to H. So it just goes back to the basics of what an exponential function's equation looks like, what represents a shift left and right and up or down, and trying to get your expression to represent represent those translations. Right, so just a nice question. Like I said, I thought it was quite a nice question. Mark allocation 5 up, 2 left. Again, unfortunately, no marks for your working out, but you do obviously need to do the working out in order for you to get the answer. I would be very impressed if you could figure out the shift left or right without any working out. Personally, I know that particularly for exponentials, I can't figure out a left or right just by looking at my expression or looking at a graph. I would need to go and work it out. But again, if you can do that, great. All right, so there is the whole of question 5. You can take a screenshot. We will be moving on to some calculus revision next week. So come with questions if you have any. And remember, guys, if you do come across past paper questions that you're struggling with, just pop it on the Google Classroom and I will have a look and help you. But once you've got your screenshots, you are more than welcome to go. I hope you enjoy the rest of your week.